It is the year 1937 in the West Nile district of Uganda. A woman is fetching water on a hot August afternoon. As she is occupied with filling her pot, she is unaware of the mosquito buzzing in her ear. This female mosquito, on the prowl for her next blood meal, spies a patch of exposed flesh. She flies closer and closer, buzzing all the while. What happens next will mark the beginnings of one of the most prevalent mosquito-transmitted viruses on Earth. Stay tuned to find out more. Welcome back to another installment of Infection Investigators with your hosts, the Fantastic Five. In this episode, we'll explore the world of West Nile virus, one of the earliest arthropod-borne viruses discovered by humans. Let's get started. Curious to know what happened to West Nile's first human host? After seeking medical attention for her high fever, doctors were able to isolate this new virus from her blood. It is believed that the female mosquito obtained the West Nile virus by feeding on an infected bird. Birds are known to be the natural hosts of West Nile virus, with their wide migration patterns allowing the virus to move to new and further geographic regions. Female mosquitoes, primarily of the Culex genus, particularly the Culex pipiens species, are the vectors of this disease. After taking a blood meal from an infected animal, the virus travels into the digestive system of the mosquito, where it replicates within the blood. Over time, the replicated virus travels to the salivary glands of the mosquito, where it lays in wait until it takes a new blood meal. The mosquito may then infect either a human or another animal. However, these victims are dead-end hosts, as the virus cannot be transmitted from person to person or animal to person by way of casual contact. If we take a look through the microscope, we can observe this virus in greater detail. West Nile virus is a member of the Flaviviridae family, along with the dengue virus and the yellow fever virus. It is a 50 nanometer wide, single-stranded RNA virus that has an enveloped capsid and an icosahedral shape. West Nile virus, like all viruses, is unable to reproduce without help. The virus infects the cells of its host and manipulates the cell's processes to then replicate itself. After the virus is injected into the bloodstream, it multiplies and is then carried to the brain to affect the human host's central nervous system, where severe symptoms can develop. Symptomatic patients may experience nausea, fever, vomiting, or develop a skin rash. More serious symptoms may occur if the virus breaks the blood-brain barrier and spreads through nerve cells, resulting in encephalitis or even vision loss. The chance of catching West Nile virus, however, is low, since only about 1% of mosquitoes carry the virus, and only 1% of humans who are bitten will go on to develop severe symptoms. Only 20% of infected individuals will show symptoms, but the elderly and the immunocompromised are most at risk for developing more severe symptoms, such as West Nile fever or the neuroinvasive form of the disease. However, the long-term morbidity is still relatively unknown. As for treatment, there are currently no effective treatment strategies clinically available for humans. The most effective control strategy involves preventative measures that inhibit vector propagation, such as disposing of stagnant water, and reduce contact, such as minimizing exposed skin outdoors, reducing outdoor activities during high mosquito periods, and using an insect repellent that contains DEET and some sort of lemon eucalyptus oil. At the larger scale, widespread application of environmentally friendly larvicides and aerial spraying both minimized the amount of adult mosquitoes present. These practices are especially important during the evening and early morning, when mosquitoes are at their most active. We will be back after a short commercial break. Stay tuned.
Stop! Are you traveling to a temperate region? Are you aware of West Nile prevention? Well, first of all, you aren't wearing the right attire. Much better. However, next time you should wear a brighter color, since mosquitoes are attracted to dark colors. Before you go outside, you have to apply mosquito repellent as a preventative measure. This mosquito repellent has DEET. Wait, you have to stay away from water. Not that water, the waterfront. Mosquitoes like to be in this area.
Always surrounded by mosquitoes? Tired of the buzzing noise? Or just having a bad hair day? Well, with Mosquito shampoo, say bye-bye to mosquito and say hello to beautiful you.
The product Mosquito Off makes no guarantee that the product works for mosquito repellent, not for good hair.
Here is a real live demonstration of Mosquito.
Every day, yeah. Ooh, baby, I love your way. Every day. Shadows grow so long before my eyes, and they're moving.
To pick up where we left off, let's talk about some of the environmental factors that affect the transmission of West Nile virus. The first factor that we will be looking at is the ambient temperature. Temperature plays one of the most important roles in West Nile virus transmission. The optimal temperature range for the Culex mosquito survival is between 25 and 28 degrees Celsius. Within this range, increased temperatures speed up biochemical reactions within the mosquito and allow for increased activity, growth, development, and reproduction. Precipitation patterns influence the development and reproduction rates of mosquitoes, and consequently the relative abundance of mosquito vectors. Since 3 of the 4 main life stages of mosquitoes are aquatic, the ability of mosquitoes to breed and reproduce depends on the availability of motionless water. Increased precipitation provides more breeding sites for mosquito vectors and may lead to more abundant mosquito populations, which could increase disease transmission. The opposite is true for decreased precipitation. These biophysical factors are important in light of recent climate change. The combination of changes in temperature and precipitation patterns will likely affect the transmission of West Nile virus. By 2080, it has been predicted that the virus will be prevalent in parts of southern Canada and as far as northern British Columbia. The third factor that we will be looking at is relative humidity. Although the link between humidity and West Nile virus is somewhat limited, there have been studies that show the impact of humidity, precipitation, and temperature together, but humidity hasn't been isolated as a single cause itself. The last environmental factor that we will be looking at is bird migration. Though mosquito populations are the most studied in terms of changing West Nile virus transmission patterns, climate change will also affect other species. Because birds are migratory species and are the primary hosts for West Nile virus, their flight patterns help to determine the geographic distribution of West Nile virus. With changing weather conditions, migration patterns are forecasted to change, with expansion into new geographic regions. This will likely affect the transmission patterns of the virus. In summary, we learned that the West Nile virus is a member of the Flaviviridae family, is a single-stranded RNA virus, and is 50 nanometer wide with an enveloped capsid and an icosahedral shape. We also learned that birds are the natural hosts, mosquitoes are the vectors, and humans and other animals are the dead-end hosts. Symptomatic patients may experience nausea, fever, vomiting, or develop a skin rash. More serious symptoms may occur if the virus breaks the blood-brain barrier, resulting in encephalitis or even vision loss. There is no treatment for humans, though there are preventative measures that inhibit vector propagation that are very effective. The environmental factors that we looked at were temperature, precipitation, humidity, and bird migration. That's all for now, folks. Tune in next week for a spotlight on malaria.